So far, we've been using an equation of the line called slope y-intercept form. That's an equation in the form y equals mx plus b. We call this form slope y-intercept form because we can look at the equation and we can read the slope from the equation and the y-intercept from the equation without doing any real work. Okay, as an example, if I have an equation like y equals negative 3 halves x minus 6, I know just by looking at the equation the y-intercept is 6 and the slope is negative 3 halves. There are other ways to express equations of lines. And one of those ways is in a form called standard form. And standard form looks like ax plus by plus c equals 0. And there are a few rules to follow when using standard form, and those rules are a, b, and c have to be integers. A and b cannot both be 0, and a is positive. When we say that a, b, and c have to be integers, we mean no fractions, no decimals. Let's look at some examples. Some examples of standard form equations of the line: 7x plus 3y plus 2 equals 0. Or 2x minus 4y minus 3 equals 0. Or 100x minus 2y equals 0. We don't always need a c value. These are all examples of standard form equations of a line. So here's a question we can tackle. Is negative 3x plus 2y minus 10 equals 0 an equation of a line in standard form? And the answer is no. Remember from our definition that the a value must be positive. So we can fix this equation, negative 3x plus 2y minus 10 equals 0, and we can turn it into a standard form equation of a line by multiplying the left-hand side and the right-hand side by negative 1. So this has the effect of changing all the signs to their opposite. And now I have an equation in standard form. Let's try this. Graph y equals 2x minus 6 and the standard form equation 4x minus 2y minus 12 equals 0 using a table of values. So we'll set up our table of values. And we'll start with our first equation, y equals 2x minus 6. And we'll just keep this easy. We'll go 0, 1, 2, up to 3. If I plug 0 in for x in the first equation, 2 times 0 is 0. My y value is negative 6. If I plug 1 in for x, 2 times 1 is 2. Take away 6 gives me negative 4. And now I can see my pattern. I'm going up by 2's. So there's my table of values for y equals 2x minus 6. Let's do the same thing for the standard form equation. So I'll take my standard form equation, 4x minus 2y minus 12 equals 0. And now I plug 0 in for x. Now I have a little bit more work to do because I have everything on one side of the equal sign. I need to bring that negative 12 to the other side. It becomes positive 12. I need to divide both sides by negative 2. 12 divided by negative 2 is negative 6. And already you should notice that the work we had to do in the first example, the first equation, and the work we're doing for the second equation is a lot more involved. So right away we can notice that it's easier to graph equations of lines when they're in y equals mx plus b form. So let's stop this example. We're not going to graph this anymore. Let's look at some different equations and let's see how we can rearrange equations in standard form to express them in slope y-intercept form. So express in slope y-intercept form, that means we want to write it as y equals mx plus b, which means I need to move everything that isn't the variable y over to the other side of the equal sign. So when I bring x to the other side of the equal sign, it becomes negative x. When I bring negative 3 to the other side of the equal sign, it becomes positive 3. And now if the question was to graph this, I could quickly see that the slope of this equation is negative 1, and the y-intercept is positive 3. Let's try another one. X plus 2y minus 6 equals 0. Again, I want to write this in the form y equals mx plus b. So I bring everything that isn't the y variable over to the right-hand side. And then my last step is to divide every term by 2. I get negative 1/2 x plus 3. My slope is negative 1/2. My y-intercept is 3. And last example, 6x minus 3y minus 15 equals 0. Express this in slope y-intercept form. So I bring everything to the right-hand side. When I bring the 6x term over, it becomes negative 6x. Negative 15 becomes positive 15. And then I'm dividing all terms by negative 3. I can do some simplification. Negative 3, negative 6 divided by negative 3 is positive 2x. Take away 5. So I couldn't really tell what my slope or y-intercept would be by looking at the standard form equation, but by rearranging it, I can see my slope is 2 and my y-intercept is negative 5.